Susan Freed and Sandy Houck. Susan is the project manager for the Energy and Sustainability Division of the County of San Diego since 2013. Her work at the county includes finding opportunities to increase the energy and water efficiency, sustainability of county operations, studying the feasibility of innovative solutions, the developing programs and projects to implement promising findings. She has hands-on experience with the challenges in creating sustainability momentum in the public sector. Previous to her position with the county, she worked for many years as an architect, involved in the sustainability projects such as the first straw bale post office in New Mexico, architecture planner, working with public and nonprofit clients to develop sustainability planning and facility master planning, and economic development professional, 10 years with the Historic Preservation Community and Development Program on Main Street. She holds a master's in architecture from the University of New Mexico, has been a lead AP since 2005, that's the very earliest of the earlies, and a certified energy manager since 2015, highly qualified individual. Sandy Houck, which I hope I'm saying last name correctly, is the Director of Engineering at Stok. She has over 20 years of experience helping her clients achieve high performance, zero energy buildings. She's provided management and verification and monitoring-based commissioning services to over 50 projects, pursuing LEED and zero energy certifications. Sandy has written and implemented dozens of measurement and verification plans. She's developed an air tightness process for successful submetering and supported her clients' ongoing energy management and zero energy performance through operational data analysis. Smart person. Among her notable projects is the Alpine Branch Library for the County of San Diego, the first zero energy library certified by the Living Building Challenge, which means it was all electric back when it wasn't cool. She was cool. So, are you there? Can you share your screen, please? Susan?
This is Susan.
Sandy?
Can you hear me?
You got Sandy there too? There she is.
Can you hear me?
I can hear you, Susan. Sandy needs to take herself off of mute. Sandy, can you unmute yourself? Oh, Susan, why don't you take over and we'll make sure Sandy.
Let's try. Can you hear me now?
Now we can hear you. Perfect.
Okay,
take it away.
Perfect. Can you see my screen?
We can, although it's a little bit funky. Oh, and that's like it's very tiny in the Zoom screen. It seems like
I will. Let me just swap. How's that?
It's even tinier now. Somehow I have to make it.
Oh, okay. Let me stop sharing and share the other screen. All right, how's that?
Perfect.
All right, cool. We got the techno right. Okay. Oh, thank you for that introduction. Sandy and I are going to have to talk quick because we're short on time now. But we want to talk about our zero net energy projects at the County of San Diego, which are also, as you pointed out, all electric projects. Why is my screen not advancing? Okay, there we go. So we're going to talk about why we build Z&E and what we have in our inventory to date, what makes it Z&E, and then the details that everyone's going to want to know is the importance of monitoring and the lessons we've learned from this interesting process. So just for starters, we started building zero net energy because of a strategic energy plan that the board adopted in 2013. And it had on as one of the goals amongst many to try, in quotes, Z&E to save energy. So the first capital project that we had in the pipeline was the Alpine Library. You've already mentioned that. So we put out a solicitation and we didn't know what we were asking for when we asked for Z&E and all electrification, and nobody else did either out there in the industry. So it was kind of experimental. But we worked with Brummett at the time, Sandy's company, which is now Stok, and we really massaged this project throughout the whole process. And we ended up with a building that actually was Z&E. It worked. And it's been net positive for 4 years. You can see from this graph, usage is the bars on top, and production is the area below, and the red line is the net. So you can see that it's been net positive. For all the policy wonks out there, we did not go with a policy for zero net energy, even though we've been building it consistently since 2014. All of our new construction projects are zero net energy and all electric, because policy is too political. You know, maybe in Sonoma it wouldn't be, but here in San Diego, it's definitely not something you want to lock yourself into. But we have proof that it works, and we have proof that it saves energy, reduces greenhouse gas, and it makes our politicians look like heroes. So it's been a win-win. More recently, we developed this zero net energy portfolio plan, which was looking at how are we going to reduce our energy use by 50% by 2030. And this was back in the days when that was the state's goal, was to reduce energy use. Now it's shifted to carbon, so we're redoing this. But this plan looked at these different strategies for how we were going to reduce our energy use. And you can see the yellow wedge is heavily relying on new construction to be zero net energy. So this was a major initiative for the County of San Diego, and that's why we have built nothing but since then. This is our inventory. I'm not going to spend much time on this, but the red ones are facilities we have occupied since 2016. The latest one was occupied in March of last year. And the rest, the other 4 are in design and construction and will be on board at the end of this year or at the end of next year. So here's what we've got. We've got some libraries, and they're really beautiful buildings. I mean, you can't look at it and say, oh, that's a zero net energy all electric building. You can't really even tell. It's just, it meets the program. It's lovely to look at, and the insides are really nice too. We've got 4 offices. 2 of them are already occupied. The other 2 are in design and construction. We've got a nature center out in the middle of the forest, which is also working well. And we have a detention campus. This is youth in custody. Detention is very hard to do, as I'm sure everybody knows. And this is in construction right now. It should be fully occupied next year. So what makes it zero net energy? I would stress heavily that design build is an important aspect of our success because of the integrated process. The designer and the builder are working together from the beginning, informing each other about how to build it best. So if anyone is interested, design build is a project delivery I would recommend. The design elements that we have typically used, we've got passive features, but also energy efficient technologies like VRF, variable refrigerant flow, for mechanical systems, extremely energy efficient, all electric heating and cooling. We have high efficiency LEDs, the highest efficiency LEDs that were on the market at the time. So really get that LPD down as far as possible. We use daylighting as much as possible. In a library, you can imagine that that's really important. We have natural ventilation at one of our office buildings, which has been kind of spotty in terms of success, but we're working on perfecting that. We have solar thermal for water heating at one of our libraries. And of course, we have PV everywhere. That's the renewables that we've used. So here's my list of ingredients. These are critical things in order to really make new construction zero net energy work. The first thing is to study the feasibility before you ever even put a dime into design and construction. Have very tight specs. We've been working on perfecting our specs with every project since 2014. And I would say, you know, we're still in the learning process. So this document is many pages long. It's like 16, 17 pages. But it has all the information that the builder, designer and builder need to know. And you got to put it in there. You got to know what you want and put it in there. Third one is to get the right team. You got to have people who know what they're doing. You certainly don't want to experiment like we did. We've essentially been training the local industry in the San Diego region. But, you know, it's becoming more of a thing in the industry, but you don't want to build yours with an inexperienced team. So use the most advanced energy efficiency technologies that you can, and make sure that you have a system to measure and verify, because if you don't, how do you know how much energy you're using? And even though we're not going to talk a lot about the occupancy phase of zero net energy, it's really critical to make sure that you're getting what you designed and built. Commissioning is super important. You got to commission not only the code required elements, but also the monitoring system. So have a commissioning agent that knows how to do that. And then, as I said, track your energy performance forever. This is my last slide. I'm just going to talk real quick about our HVAC systems. We use VRF at all of our libraries and offices and our nature center. And the reason is because at these facilities, there's a variety of different kinds of spaces that have varying occupancy and have varying needs and varying schedules. So the VRF is really super for customizing heating and cooling in whatever space it's serving. And we also use heat capture. We have heat pump package units at two places. Our archives at our assessor's office. It's a big warehouse space, 24-hour climate control, pretty high electricity use. And the heat pump package units are the best system for that kind of space. And then we also have it for detention housing, because it is very much like those facilities are very much like housing, and heat pumps are appropriate for that. And then we have a central plant at the detention campus with a high efficiency chiller and electric resistance boiler. So Sandy, take it away. Sandy, you there?
Can everybody hear me?
Yes.
Oh, perfect, perfect. Okay, thank you, Susan. So I'm going to go over the importance of monitoring. Susan mentioned that's one of the things that's really critical, and the County of San Diego includes end-use submetering on all of their new construction projects to track the zero net energy performance, and we'll talk a little bit more about how we use the metering for that. But we also have found the county has gone back into some of their existing buildings, even if they aren't pursuing zero net energy, and added submetering into those buildings as well. And we use those to do what the county calls proactive energy management, so we can track the energy performance of existing buildings. We can also use that trend data that we get for any kind of energy calculations that they need to perform for, you know, greenhouse gas emissions reporting or carbon reporting. They also can use those submeters to show energy savings due to any retrofits that are done on the existing buildings. Next slide, Susan. Oh, there we go. So you could verify that a building is ZNA by just using your utility data alone, but utility data is not helpful at all when things aren't going in the right direction. So as you can see on this, you know, on the left-hand side, this is just a really quick example of one of the county buildings that's 2,000 kWh positive for a particular year. So from our utility data, we can get the net consumption for the building. We can get it for the whole entire year. We can get it monthly. We can get it interval data. But from utility data alone, you cannot tell how much the building is actually consuming or how much the PV system is actually producing. So go ahead to the next slide, Susan. The county has chosen to put in end-use submetering.
I don't know why it's not, there we are.
So at a minimum, the county chooses on all new construction projects, and you know, we try to do this on their existing projects as well. We try to put in end-use metering that's as clean as possible to get HVAC, lighting, and plug loads separate. So that's the minimum. And in addition, if PV is part of the project, we also submeter the PV, and I have more information on that coming up. Some of their projects, we have electric vehicle chargers. Sometimes there's larger pieces of equipment that we monitor, but just as a general rule, we try to separate out HVAC, lighting, and plug loads. This then tells us not just how much energy is used in the building, but how it's being used in the building. Next slide, Susan. But how much energy should the building be using? So that's a question we always want to look at. We could read all of the submeters and just take it at face value, but what the county has chosen to do is create energy models for their buildings to provide predicted energy use. This chart that we have here just shows the predictions from an energy model are in the lighter colors, so light blue for HVAC, light yellow for lighting, and light green for plug, and then the actual use is the darker bars. And you can see that, for example, in the month of September, the HVAC use was higher than the predicted. And, you know, that could be, you know, we'll research what that is. So that could just be that that month was hotter than we anticipated. It could be that the occupancy load has changed in the building. Next slide. We can dial down, which this is the part that, you know, we always find fun to do. We can dial down into the interval data and look at this from a weekly, daily, hourly perspective. So then we can find out, well, when are things operating? Are they operating outside of the schedule? Is the HVAC operating on a Saturday when we don't expect it to be? Is the lighting operating overnight when we don't expect it to be? So all of this data that we're pulling in from all of these meters gives us lots of information about how these buildings are operating. And over the years of doing this, we've learned a lot of lessons. Next slide, Susan. So one of the first, this is an example from a library for the county. There was a wildfire out by this library that knocked out the power, and it erased the schedule in the VRF system controller. So as you can see, on Friday, August 17th, in the middle of the day, the VRF system started running 24/7. So if we were just using utility data to track the Z&E performance on this building, we may not have known about this for a long time, but because we have this kind of data and we can look at it at any time, this was able to be identified early, and especially on a Z&E building, you don't want this kind of activity to go on, or you're going to jeopardize your zero net energy. Next slide. This one's interesting. This is another library for the county. This is so on this particular building, they have a traditional electric water heater with a tank. The water heater is on their plug load panel. And so we started reviewing the data once we started getting some, and noticed that something was cycling on and off all night long. Turns out this water heater obviously is always trying to keep the temperature of the water at a specific temperature. And even when we tried to put it in eco mode, it would only reduce the temperature by about 20 degrees. So this is a library. There's not a whole lot of need for hot water. So one of the things we've gotten out of this is, in a building like that where there isn't a whole lot of need for hot water, it's recommended to to use Insta-Hots or point source water heaters. Even though that looks like very little amount of energy use, as we all know, that can add up over time. So definitely in the Z&E building, we don't want to have any excess energy if we can help it. Next slide, Susan. This one I would say is super critical, and I recommend this on every single project that I work on that puts in PV system, whether you're doing zero net energy or not. Always put in a submeter to read the PV. And there's several reasons for that. A lot of projects that we've worked on have had issues like faulty inverters and faulty modules. This is an example of, actually it was at Nature Center at Santa Isabel in San Diego County. We started getting the data from the PV system, and it was just really wonky data, strange behavior in the morning, random days with little to no production. So with the meter for the PV system, we were able to call the PV contractor back out. They identified some programming issues and some faulty modules, and those will be fixed, and the project will be back on track for zero net energy. But one of the things I would one of the reasons that I highly recommend your own PV meter is that even if your project has third-party monitoring, our experience with that is that we are the ones that tend to tell them that there's something wrong with the PV system. I'm not sure why, but for some reason, the third-party monitoring systems and contractors don't usually identify these. So it's really critical. So even if you have a project where you add PV, you don't have enough money to add in end-use submetering. If you could only add one meter, I would add it on the PV, because with the PV submeter and your net utility data, you can at least figure out what your building consumption is and what your PV system production is, and keep an eye on that PV system. Last slide. So Susan and I, as she said, we've been working on this for like 7 years. We've been working together on projects like this. And I would say one of the biggest things that we've learned is that submetering is challenging. You really have to have somebody to kind of give oversight on this the whole way through. And it's best to start early. So as Susan mentioned, a lot of the stuff that we've learned, all these lessons that we've learned have made it into the county's RFPs. So writing explicit requirements is critical from the beginning. Reviewing the drawings and specs the whole way through to make sure that the meters are in there with the proper specification, the proper communication protocol. All of the county's meters come into their building automation system, so it needs to speak the correct communication protocol. And making sure they're all interconnected, making sure there's conduit where there needs to be conduit. And then at the end, commissioning, making sure the meters were installed properly, reading properly, programmed properly. It's a really labor-intensive process, and Susan and I are there reading the data long after the contractors and the designers have gone away. So we have a really big stake in making sure that this process goes well. That's it. Last slide. Whew, we did it before 2:30. Or sorry, East Coast time.
Thank you for catching us up there. There's a whole bunch of questions over here on the side. I think that on the topic of metering that you're just speaking to so well, people want to know what does it cost? And I'm sure like the gross cost must be hard. Do you have a sense of, does it add 0.1% to the budget, 1% to the budget? Do you have any rules of thumb of what does it cost to keep track of things?
Well,
you know, go ahead, Susan.
the equipment is really not the expensive part. It's the labor. And if you've got people out there already, you know, installing electrical equipment, doing controls programming, it's not a huge added cost. And it's so worth doing. What were you going to say, Sandy?
Pretty much the same thing. I was going to say the materials themselves, although the contractors would probably argue because they, you know, $1,000 meter, I feel like in the grand scheme of things, it's not a huge cost, but there is obviously labor involved in that, and then programming by the controls contractors. But the meters that we've worked with are really reasonably priced. There's a lot of options out there.
Okay, that is good to hear. I know that I've heard lots of chatter, like, you know, do you have a favorite? There are a whole bunch of technical questions on the chat side of this. That would you mind moving over to the chat and make sure you respond to attendees as I transition to our next speaker? Because people were loving it. We got all sorts of things they want to ask you about.
Sure,
absolutely. Well, that was great. Bravo on your accomplishments, and thank you really for showing us the importance of metering and showing, you know, how to diagnose when things go wrong. As a fellow person who does that kind of work, I see that. I'm always surprised by the things I never would have guessed were happening, and every single product type. Yeah. So with that, yay! Thank you, Susan. Thank you, Sandy.